Hello students, today we're going to go over half of lesson 10.3. Today we will be covering relative frequency and experimental probability. Okay, so when you conduct the experiment, the relative frequency of an event is a fraction or percent of the time that the event occurs. Okay, so you can see we have this kind of like formula almost like what we use. Relative frequency is equal to the total number of times the event occurs, okay, so whatever that event might be, over, so divided by the total number of times you conduct the experiment, okay? But what we are more so going to be talking about, probability that is based on repeated trials of an experiment is called experimental probability. Okay, so for this, you're going to say the probability of an event is the total number of times the event occurs over the total number of trials. Okay, so I'm actually kind of bummed out that we are not doing this lesson in school, because if we were, I would actually have us conduct a trial experiment, okay? So for example, I would have each student maybe flip a coin. I would give you a coin to flip, and the total number of trials, you would flip that coin, maybe say, let's say 20 times, okay? And I would have you count the event that I wanted you to count would be maybe flipping how many times you would flip out of those 20 times ahead. Okay, so say one example, if Bennett, for example, flipped this coin and he flipped it 12 times heads, then he would do 12 out of 20. Okay, if somebody else flipped it, maybe Natalie flipped it 20 times too, and she flipped it 9 times heads out of those 20, okay? So the number of times that event occurs would be on the top, and over the total number of times you flip the coin, the total number of trials you took would be in the denominator. Okay, so let's take a look at this finding experimental probability. It says the bar graph shows the results of rolling a number cube 50 times. Okay, so that's the total number of trials. What is the experimental probability of rolling an odd number? Okay, so we already know just by reading this that the denominator is going to be 50 because they had 50 trials. Now we need to add up every time that they rolled an odd number. Okay, so they rolled a 1 10 times. Okay, so we have to add up 10. Plus they rolled the 3, which is also odd, 8 times. So I add up 8, and they rolled this 5 11 times. So add a 5, and those are all of the odd numbers, okay? And they rolled that a total of 23 out of those 50 times they rolled an odd, okay? So why don't you pause the video now and use the same thought process to try to find the experimental probability of rolling an even number. Okay, so this, they did a total number of 50 trials, again, even, so we would be looking at 2, 4, and 6. They rolled a 2 4 times. They rolled a 4 11 times. And they rolled a 6 6 times. Again, we are seeing that on this axis, times rolled, right? So then you would have to add them up, and you would get 21 out of the 50 times they rolled an even. Okay, moving on. Now that we know how to calculate the experimental probability using this formula, number of times the event occurs over total number of trials, we can use the experimental probability to make a prediction. Okay, so it says it rains 2 out of the last 12 days in March. Okay, if this trend continues, how many rainy days would you expect in April? Okay, so you could say that the trials, the total number of trials we had were 12, because that's how many days they predicted. And the event that rain occurred happened twice. Okay, so 2 out of the 12 times. And now we have this fancy calendar, not a calculator, that tells us how many days there are in April. So there's 30. So we want to see how many we could predict out of a total of a new kind of experiment out of 30 days. How many would we expect? So we are setting up a proportion. Okay, so now we have to cross multiply and divide. So we do 2 times 30, so 2 times 30, and that is equal to 12 times x. 2 times 30 is 60. And when you divide both sides by 12, you get 5 equals x. Okay, so let's go back to the problem. It says, if this trend continues, how many rainy days would you expect in April? So we would expect 5 rainy days. Okay, so we can do this because we are looking at the total in the denominator, right? And in the numerator, it is the event that it rains. Okay, so we have another very similar example. Why don't you pause this and try to do this on your own now, and then we'll go over it. Okay, so it says, at a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. Okay, so they did this quote-unquote experiment, and out of the 200 jeans they looked at, 5 were defective. Okay, if this trend continues, okay, the same kind of rate, about how many pairs of jeans would you expect to be defective in a shipment of 5,000? Okay, so if we are now looking at a total of 5,000, we want to know x, how many would be defective? So now we need to cross multiply and divide again. 5 times 5,000 is 25,000, and 200 times x. We get the x alone by undoing the multiplication by dividing. So we divide both sides by 200. And we get 125 jeans would be defective. Would be expected to be defective. Expected to be defective. Okay, that's not set in stone. That is just if this trend of 5 out of every 200 continues, right? Okay, so today we looked at relative frequency. We won't do a lot more with that besides kind of define it. And then we looked at the experimental probability, okay, which is the total number of times the event occurs divided by the total number of trials. And we then were able to use experimental probability to make a prediction.